Okay, I want to introduce Jim Burch to give the keynote talk, and I've known Jim almost a half a century. We arrived at Rice 1 year apart, Jim in '64 and I was there in '65. It's been delightful to know him and interact with him. We worked together at NASA in Huntsville for a while before Jim went home to San Antonio, to Southwest Research, where he's had a distinguished career. Jim continued the Yosemite tradition very extensively through these years since the mid-'70s, and has, I don't know how many meetings it's been, Jim, but I know a lot.
I don't either.
That you and your folks have been here and have facilitated this. Jim's made tremendous contributions, as you all know, in space physics, and I thought I might show you what Jim did scientifically when he was about 30 years old. So let's see.
The third case is the one I'm going to talk about, and that's where you have a substorm and you produce a region of detached plasma in the afternoon sector, or a plasma tail, or some isolated region of cold plasma. The protons and electrons that are injected during the substorm or during the magnetic storm can have the possibility then of drifting into the detached region or isolated plasma region. It's might not be that simple because this plasma region is going to have a drift motion as well, and so when the satellite passes through, you don't really know how long before you went through the energetic particles reached the isolated plasma region. Also on S cubed, the apogee is only 5 1/4 Earth radii. So in fact, we've looked at about 8 or 9 months of data when the apogee of the satellite was out in the region where these isolated regions occur in the afternoon sector. We found only 4 cases, and all of these that happened were in the main phase of magnetic storms. That is, they were probably isolated regions or detached regions at other times, but they were just simply beyond the S cubed orbit. And so it turns out that in all of these cases we had a hot plasma distribution in the ring current. The plasma sheet was drifted into the isolated region, but in all cases the beta of the plasma was at least 1. And so these calculations of ion cyclotron turbulence, the resonant energy that Don Williams was talking about, really doesn't apply because those calculations are made for in the low beta limit. And so we have to consider possibilities such as the high beta ion cyclotron instability or the electrostatic ones that Dick Thorne was talking about, and I'm not qualified.
Okay. Jim Burch.
Follow me?
Yep.
All right.